In this problem, we're talking about a baseball and a fan, and we want to see where they intersect each other. The baseball follows a parabolic path, so it's going to be in the shape of a parabola. And then the fan leaps into the air following a straight path, so that's going to be represented by this line. Normally, I like to do the easy part first, but because we're going to be graphing, I want to do my table for the parabola first, just to see if I need to scale anything. Now I want to draw your attention here. It says use the method of your choice. You can graph or solve it algebraically to find the points where the path of the baseball and the fans intersect. So because you may have a different opinion than somebody else, I'm going to show you both ways. I'm going to do graphing first, and like I said, I'm going to do the parabola first. Now, normally when we graph parabolas, I would say you need to have 5 points total, and you use negative b over 2a to figure out what the middle of your table is. But because this is modeling a real-world situation, I want to see where the baseball is hit, and I want to see where it hits the ground. So I want to see the whole path of the parabola. So I'm always going to start at the point 0, 0. And then I'm going to look at the table of values in my calculator, and I want to go all the way until my y value gets back to 0. So I'm looking at my calculator, and it looks like that happens when the x value gets to 8. So that means I'm going to copy down all the y values from 0 to 8. All right, so those y values are 1, 7, 2, 12, 3, 15, 4, 16, and then they start to mirror each other again, so back to 15, 12, 7, and then back down to 0. So if you look at my graph, we're going to be good here, because my graph, the y values go up to 17, and the highest y value that I have on my table is 16. So we're going to be fine. We don't have to do any scaling. So I'm going to start plotting my points here. 0, 0, 1, 7, 2, 12, 3, 15, 4, 16, and then we start kind of working our way back down. 7, 7, and then 8, 0. So at 0, 0 is where the baseball is hit, and then at 8, 0 is where it hits the ground. All right, now as far as the line goes, that one's not going to be so bad. My y-intercept is 14, and my slope is negative 1. So I'm going to go down 1 and right 1, and I'm going to keep going until I hit the x-axis, because I also want to see where the end of this graph takes me. So I have all these green dots. All right. So now what's really important here is where the two graphs cross each other, and it happens in two places. Once here and once here. So the solution, the two solutions would be the points 2, 12, which is this one right here, and then this point, which is 7, 7. So if you were solving this graphically, this would be your solution. If you were going to solve it algebraically, I would use substitution. I would put negative x plus 14 on the left and negative x squared plus 8x on the right. Normally I would put my quadratic term on the left, but because it's negative, I put it on the right, so that way when I add it to both sides, it becomes positive. And then I also need to subtract 8x, because I still want to get 0 on the right side of my equation. So what I have here is x squared minus 9x plus 14. So I have a quadratic. I'm going to use an easy diamond to figure out two numbers that multiply to 14 and add to negative 9. Those numbers are negative 2 and negative 7. So this factors into x minus 2, x minus 7. Now I'm going to take each of those parentheses and set each one equal to 0. So I'm going to say x minus 2 equals 0 and x minus 7 equals 0. I'm going to add 2 to both sides here, and my first solution for x is 2. And if I add 7 here, my other solution for x is 7. So I have my x coordinates. Now I need to plug those back in and figure out my y coordinates. So if I start with x equals 2, I'm going to choose to plug it back into the equation that has the green box around it. So I would have y equals negative x, which is 2, plus 14. So my first solution for y is 12. That means the point 212 is one of my solutions. And then I'm going to do the same thing here. Negative x plus, 14. So I would have y equals 7. So my other solution is the point 7, 7. And I want to show you and point out this ordered pair right here is the same as this ordered pair. And then this ordered pair right here is the same as this ordered pair. So regardless of how you chose to solve this equation or this system of equations, you should get the same solution.